All right, Chapter 2 Summary. This chapter has provided information basic understanding of servo system and the component of the following summary with a specific point for the chapter. Open loop with the control system, the control directly and only by the input signal that has the no feedback, therefore less accurate with the closed loop control system. The open loop system usually requires the operator to control the speed, direction, movement of the output. The input signal amplifier amplifies signal the motor output shaft to the low. With the control closed loop control system, most common type of the navy, it can be responded with the move loads quickly and greater accuracy. The open loop system, the closed loop system, automatic feedback system, the form of the input with the desired movement to be taken place. You have your control transmitter with a 90 degrees control transformer that is going to the stator servo amplifier servo motor to the low of the 90 degrees and back. The servo system is classified in closed loop with a system capable of accepting order with defining the desired result with evaluating from present condition the comparing desired result with the present condition of obtaining the difference of the error signal with the issue from the correcting order the change of the existing condition of the desired result with the bang of the correcting order. The basic servo system is normally made with electromechanical order that consists of the synchro controlling system of the servo amplifier servo motor, some of the form of the feedback position servo, the goal of the controlling the position of the low of the AC position servo system amplitude with the phase of the arrow AC arrow signal to determine the amount of the direction of the load will be driven. The DC position servo meter with the amplitude with the polar of the DC arrow signal are used to determine the amount of the direction of the load be driven. Input signal of the stator with the amplifier of the motor with the load back to the feedback with the stator. The velocity servo, the input servo with the amplifier motor low with the feedback of the servo. The velocity servo obeys for the same principle arrow signal generation of the point position of the servo. Expected velocity of the output is sensed rather than the position of the lobe when the velocity loop of the corresponding with the arrow signal is still present with the lobe the moving is desired velocity. The resistor 1 with the 45 negative 45 input with the result with the resistor 2 and his stator error signal amplifier motor lead feedback same motors resistor 1 back to resistor 3 back to servo. Alright, the acceleration servo is similar to the velocity of the position servo. They expect with the acceleration load being sensitive rather than position velocity, and the slope of the tachometer velocity replaced with accelerometer time lag servo. The character of the geometry defined of the time of the between the input and the signal of the actual movement of the load. The time lag is desired and reduced through the use of the high gain of the amplifier dampening system. Added to attain the smooth and efficient operation. An overload dampening will not be subject to the oscillation because of the excessive amount of the time of the reach of the synchronization under dampened the system provided the initial response of the error signal, but result of the load oscillation about the point of the synchronizing with somewhere between the overdampened and the underdampened design achieve the under adequate accuracy, smoothness, moderate shortening, synchronizing time. The show of the angular displacement, previous position, new order position, under damping, over damping time. Damping is usually used to stabilize the system, minimize eliminating problems, overshoot with the system form with the friction clutch for the damping. The magnetic clutch damping is similar inflation clutch. The difference if the flywheel is coupled to the shaft of the servo motor, the maintenance coupled with the magnetic field to draw the two friction plates together to produce the damping. And another method to use the magnetic field is to pair with a coil with the one coil with the junction with the conducting surface of the flywheel to produce the damping. Air rate damping is defined with the method of the damping the anticipated amount with the overshoot, the form of the damping correctly overshoot with the introduced the voltage of the error detector with the proportional rate of change of the error signal and stabilization network. Even the error rate with the damping consists of either the resistor capacitor different or RC different network with the integrating network with a component of the resistor and the capacitor network chosen to tailor the stabilization network to the requirements of the servo system. Error detector going through resistor 1 and capacitor that should network into servo amplifier output. The frequency response to the servo range of the frequency and the system able to respond with the moving load with the ideal system of the respond with the wave with the frequency present with the input the signal. The frequency response good way the judging the servo performance the given the servo system good. Frequency response provided the maximum stability with the maximum time minimum time lag position order in the time position order in the load with the magnetic oscillating phase different from the order. Load mag oscillation and amplitude with the different from the order. The bandwidth of the servo amplifier ideally must be able to accept only the range of frequencies represented by the servo signals. The amplifier bandwidth is another compromise that achieving the optimum servo operation. Your pentometer is one of the simplest position sensor devices that generally used because of the small size with a higher accuracy output with which either the AC, DC, or the primary disadvantage of the limited motion limited life due to the wire with a higher torque with the requirement to rotate the wiper contact position balance point pedometer is closed loop with the servo system voltage divider with the deflection as position sense for the produce the air voltage with the fed of the servo amplifier. Alright, your balanced pedometer supply voltage resistor 1, resistor 2, the input shaft, and servo amplifier motor and the mechanical response output shaft going from the motor back to the surveillance panometer from the load. Summing network can be used with air to detect the servo system to be add algebraic 2 or more input feedback air voltage. You have voltage 1, voltage 2, voltage frequency. Summing network resistor 1, resistor 2, resistor frequency. Range frequency with the servo amplifier motor and output shaft tachometer back to the summing network. The E-transformer magnetic error detector that can be used with this system limited to larger angular movement with the output signal with either phase 180 degrees out of phase depending on the direction of the E-transformer armature motion. The amplitude of the signal is determined by the amount of the armature. And basically, the E-transformer can only detect with only one axis. The armature, shows your E-transformer. The show of the armature sliding. The cost of E-transformers to pick up with the load. Two with the E-transformers play with the right angle with each over the top of the air detector is capable of detecting the both horizontal and vertical direction. The control of the transformer when used with the magnetic air detector can rotate with the unlimited angles. Output with the type of the control transformer that always use with the servo air with the signal that must be with the demodulated. If you with the DC servo meter, the rate generator of the tachometer may use with the velocity of the servo loop with the heart with the feedback with the attack sensing velocity speed with the low with the tachometer can either be the AC or DC rate with the generator output frequency. The AC tack is same with the reference frequency varying only with the pave depending on the direction of the rotation. So that the this show of the undistorted line primary reference for coil with the AC supply, the secondary output stationer is the air coil with the zero input with the aluminum copper cup rotator and stationary iron core modulators. Or you can change the DC air signal into the AC input air signal for the servo amplifier. The device is required with the servo amplifiers or even install with the DC amplifier. Demodulators convert the AC air signal to the DC air signal. The DC signal is required to drive the DC servo amplifier. Servo amplifiers use the AC or DC servo system must have the flat gain with the minimum phase with low output impedance, low noise level. AC servo motors use the servo system that move a light load with large AC motors. Two load inefficient servo with large loads to be moved. DC servo motors control the heavy load with widely used with the servo system. The speed direction DC servos can be used either with a bearing in the armature current with the magnetic amplifier. Use the power with the conventional servo amplifier is too small to drive the large servo meters with either AC or DC. And multiple loop servo system combines several closed loops and open servo loops together to combine and control a common load. And that was chapter 2's summary.